Hey there, and welcome. So, you've ever stared at a trig equation and just had that feeling that things were about to get complicated? Well, you're in the right place. Today, we're jumping into the deep end and tackling those advanced problems you find in Precalculus, the ones that build on everything you've learned so far. Let's get into it.
You see something like this, and your brain just stops, right? Cosine of 2x equals cosine of x. I mean, where do you even begin? They have different angles. It definitely looks intimidating, but I promise you, by the time we're done here, you'll see a super clear path to solve this and a whole bunch of others just like it. We're going to get you unstuck, for sure.
So how do we level up to tackle these tougher equations? Well, the secret is that you don't actually need a bunch of brand new math skills. It's all about cleverly combining the fundamentals that you already have down.
Just think about it for a second. You're already a pro at solving stuff like sine of x equals 1/2, and you've got your Pythagorean and double angle identities in your back pocket. All we're going to do now is weave those two skill sets together to break down these tougher-looking problems. It's really just the next logical step up.
To do that, we need the right tools for the job. I want you to think of these next three strategies as your personal toolkit for advanced trig equations. Once you get the hang of them, you'll be able to look at a problem and know exactly which tool to pull out.
So, what's in this toolkit? First, we have recognizing and solving equations in quadratic form. Second, using identity reduction to simplify things. And third, a special strategy for handling multiple angles. You know, like that cosine of 2x we saw a minute ago. Let's break down each one.
First up, the quadratic form. And trust me, this one is a total game changer. If you ever see a trig function that's squared, the same function to the first power and then a plain old number, a little alarm should go off in your head that says, hey, this is a quadratic. By doing a simple substitution, like letting u equal sine of x, you can magically transform a scary trig equation into a basic algebra problem you've been solving for ages.
Next in the toolkit, identity reduction. The whole goal here is just to make things simpler. If you've got an equation with a messy mix of sines and cosines, or maybe different angles, your mission is to use an identity to rewrite it. You want to get everything down to just one single trig function. That makes it way easier to solve.
And our third tool is for those multiple angles. When you see something like sine of 2x or cosine of 3x, the go-to move is almost always to pop open a formula, like a double angle formula, to expand it. This breaks it down into terms that only have a single x. Then you can factor and solve. Just don't forget that final step of actually isolating x.
Okay, enough with the theory. The best way to really get a feel for these tools is to put them to work. So let's get our hands dirty and walk through a few examples step by step to see how this all comes together.
All right, first one up. Take a look. You see that cosine squared of x and then the plain old cosine of x? That is your giant blinking sign to use the quadratic form. So first step, we do a little substitution. Let's say u equals cosine of x. Now our equation is a much friendlier 2u squared minus u minus 1 equals 0. We can factor that, right? It becomes 2u plus 1 times u minus 1 equals 0. That tells us u is either negative 1/2 or u is 1. Now for the most important part. We have to back substitute. So we solve cosine of x equals 1, which happens at x equals 0. And we solve cosine of x equals negative 1/2, which happens at 2 pi over 3 and 4 pi over 3. And there you go. Those are our answers.
Okay, example 2. Sine squared of x equals 1/2. Your gut instinct is probably to take the square root of both sides. And you'd be right. But, and I cannot stress this enough, you have got to remember the plus or minus. That means sine of x isn't just root 2 over 2, it's plus or minus root 2 over 2. So now we really have two little problems to solve. For the positive case, we look at our unit circle and find pi over 4 and 3 pi over 4. For the negative case, we find 5 pi over 4 and 7 pi over 4. 4 answers in total. See how easy it is to miss half of them?
All right, remember that problem from the very beginning, the one that looks so tricky? Cosine of 2x equals cosine of x. That 2x is our clue. We're dealing with a multiple angle, so we need an identity. Now, you know there are a few different versions for the cosine double angle identity, right? So which one do you pick? Well, the smart play is to choose the one that will leave us with only cosines. That would be 2 cosine squared of x minus 1. We'll substitute that in, move everything over to one side, and we get 2 cosine squared of x minus cosine of x minus 1 equals 0. Now, hold on a second.
Does that look familiar? It absolutely should. It's the exact same quadratic equation we solved in our very first example. This is one of those awesome aha moments in math. It shows you how powerful these strategies are. We just turned a complicated multiple angle problem into something we already know how to solve. And because it's the same equation, guess what? We already know the answer. We don't have to do all that work again. We know the solutions are x equals 0, 2 pi over 3, and 4 pi over 3. This is what it means to work smarter, not harder. Recognizing these patterns is a huge part of getting good at math.
Okay, so you've got the tools. Now let's talk about the traps. These are the little things that can trip up even the best students, so knowing about them ahead of time is the best way to make sure you don't fall for them.
Seriously, look at this. This is probably the #1 mistake I see. It all comes down to that tiny little plus or minus symbol. When you take the square root of both sides of an equation, you have to account for both the positive and the negative root. As we saw a minute ago, if you forget that symbol, you are guaranteed to miss half of your solutions. Don't let that happen to you. So let's recap the 2 big traps to watch out for. Number 1, never ever forget the plus or minus when you take a square root. Number 2, be careful about extraneous solutions. This can pop up if you ever have to square both sides of an equation to solve it. Sometimes that process creates answers that don't actually work in the original problem. The only way to be safe is to always plug your final answers back into the very first equation just to make sure they check out.
So I know what some of you might be thinking. Okay, this is great for a test, but is this actually used anywhere? When am I ever going to need this? And that's a fair question. The answer is pretty much everywhere, and in some really cool ways.
The answer is a huge yes. This isn't just about exams. This way of thinking of using tools and identities to break down a complex problem into simpler parts, it literally builds the technology all around us. Let me give you a specific, really high-tech example.
Okay, think about a big robotic arm, like one you see in a car factory. An engineer needs to tell that arm to move its hand to a very specific point in 3D space. To do that, they have to calculate the exact angle for every single joint in the arm. That whole process? It's called inverse kinematics. And at its heart, it involves solving systems of really messy trig equations that often look just like the ones we've been practicing. They use these exact same substitution and identity techniques all the time.
So look, what you've picked up today isn't just about passing your next pre-calc test. You've learned a way of thinking that helps you deconstruct complicated problems. You've added some seriously powerful tools to your mental toolkit, tools that are used in robotics, physics, computer animation, you name it. So the real question isn't just what's on the homework. It's, now that you have these tools, what other big complex problems are you ready to start taking apart?